Good evening, everyone, and welcome to all the learners from Emeritus and Eruditus. We are here for our guest lecture series by Career Services. I'm Shivam, and I'll be moderating this session. Now, if you have any questions during the presentation, please type them into the Q&A box, and I'll bring them up at the end of the session. We have amongst us today the head of data labs at HDFC Life, Mr. Sayan. With nearly 20 plus years of experience, Mr. Sayan is a business leader with proven experience in delivering sustainable and high impact growth solutions for global card issuers across multiple geographies. After earning his degree in statistics, he took up analytics for his professional career. The initial 10 years went with some of BFSI's earliest successful adopters of data science, GE Capital, American Express, and Citibank, and then onwards. He has never looked back. Over the years, he has taken progressively senior roles in developing strategies around customer engagement, cross-selling, acquisition, and risk management. At HDFC Life, he has built the data science practice group up around AI, predictive analytics, and business informatics. He worked through 5 leadership changes around him and partnered with business teams across sales and services verticals to drive business transformation and digital adoption of emerging tools and technologies across the life insurance value chain, covering sales, underwriting, persistency, cross-sell, claims, and payouts. Outside of work, he is a passionate photographer, an art history enthusiast, a curious traveler, and an avid reader. Well, with this host of experience, I can say that it is going to be an exciting and knowledge-packed session today. Please join me in welcoming our guest, Mr. Sayan. Mr. Sayan, the floor is all yours.
Thank you, Shivam. Thank you, its team, for inviting me. I'm privileged, honestly, to come and join you guys on this wonderful Friday. And here in Mumbai, the rain has subsided temporarily. I don't know how many of you would have been watching the Tokyo Olympics inauguration. I couldn't. I was in the middle of office meetings, but anyway. So I was asked to share about the role of analytics in BFSI as a whole. How did I see? So I think what I can do is I can take you about the journey that I have been seeing for the last 21 years in this sector worldwide, how it is shaping up. I started long before that. This entire data science, AI, these things became buzzwords in the industry. So I started, I'm a statistician by academic qualification. I passed out from the Indian Statistical Institute, ISI, in the year 2000. And my first job right from the campus, understandably, was in what we used to call analytics. Now it's known by various other names: analytics, data science, machine learning. The thing doesn't change. But so I have seen how the industry's approach towards utilizing data in driving business decisions, in shaping up business strategies, have evolved over the years. I have worked through macroeconomic cycles, and I have lived through the 2008 credit crisis downturn. I have started my career in the wake of the dot-com bust. I have lived through the tumultuous years of 9/11. So various macroeconomic changes I have lived through in my career to see from close quarters how the business priorities change, how the decision-making philosophy changes, and what the data science can do to support such a dynamic change as maybe the need of the hour. Okay, so at the outset, what I say is this entire thought process started mostly as 2 separate streams. One stream came from the world of mathematics, and that includes the mathematicians, the physicists, the statisticians, of course, like myself. And then there was another stream, the software professionals, the computer science people. Okay. Now, independently, somewhat, of course, not totally independent, but somewhat independent of each other, these two communities were developing themselves. So you had the Y2K problem, if any one of you have heard of it. When we moved from 1999 to year 2000, it was a famous problem, and a lot of effort was put to set things right. Then came subsequent technology evolutions, like the growth of internet, then Google, of course, in its own right, as important as the internet, rest of internet itself. Then came the era of smartphones, apps, and now we are in various stages of that. That's the technology side. You are also seeing like emergence of cloud technology and various other things from the technology side. On the other side, another stream started working, and that is where I started my journey as an analytics professional. So the first stream, until around 10 years ago, I will say broadly, was more concentrated in the technology domain. And the stream where I come from, we were using some technology, of course, to work up the numbers, but we were more satisfied in a world of maths and computation, okay, simulation, estimation. And kind of problems we used to solve is statistical regression, segmentation, clustering, okay. Kind of business questions we help to answer is who is my customer, what is the best product, how is the product performance doing, who are my repeat customers, okay. And if in the banking sector, it's not only the revenue line, but it's also about the contra revenue line, the loss lines. If I lend to someone else, how much is the loss? So we were more in this world of quant. Now, I started my career with GE Capital. That time, GE had a vast business enterprise in finance. I started as an actuarial analyst in the world of non-life reinsurance. Reinsurance is insurance of insurance companies. So these are large global firms. And that is where I started. Then I spent some time in American Express in credit cards. Then I moved on to Citibank, where I broad-based my understanding of consumer finance more with other instruments of consumer finance, not only credit cards, but home loans, personal loans, overdrafts. Basically acquiring a breadth of domain knowledge along with the functional knowledge of analytics as I went about. And it was a wonderful journey I had. But around, I will not be able to put an exact year. That will be fault, that will be misleading. So pardon me if I quote 1 year. But I will say around the year, say 2010, 11, 12, we started hearing digital analytics. Of course, that's very different, very primitive compared to what we do today, what I have been doing today. But these kind of concepts started appearing in the horizon, okay? And then shortly after that, around 2011, 12, we started hearing words like Hadoop. Nowadays, no one knows even possibly what Hadoop is, but with the emergence of cloud. But that time, this word Hadoop became very important because the tech folks, they were experimenting with distributed computing, just as we, the quant folks, we were experimenting with various quant algorithms, okay? Now you may ask me, if we were not connected with the technology, where did we run our programs? Of course, we were using our software or program. What I meant by that is the assimilation of the two things. And this is what will be important for us to understand, to know where we are headed towards. So what happened is things started to come together from a technology perspective, from a business application perspective, from a talent perspective, and from a regulatory perspective. So I will cover on these 4 pillars how the evolution has been in the last 10 years. In the technology perspective, around 2011-12, we started seeing Hadoop and all these things, Cloudera, they all started coming, and there was a big rut. Okay, oh, what is this Hadoop animal? Everyone knows that little elephant. Like we had that symbol long time ago, Apu, in 1982 Asian Games. So that was the closest I can relate. But that shortly gave way around middle of the last 10 years, 5-7 years ago in the cloud technology. So you had Amazon Web Services, you had Microsoft Azure, you had Google, okay? They appeared in. And what were they exactly helping us who were the quant person? First of all, until the emergence of this, starting with Hadoop, but on towards cloud, our application was limited to structured data, to nicely structured numeric data. We could not play around with text data, okay? So while we could say like how much will be the average spend of the customer be on the credit card, or we could say whether to accept or refuse the home loan application or the personal loan application of an applicant, or what to make out of the expected claims experience for every new customer I am issuing an insurance policy, life insurance policy. But all that thing was permitted as much as numeric data could be. Emergence of this big data technology helped us understand that we can consider more types of information as data. So first of all is the text data. As you'll be aware, or it is not hard to imagine, an organization produces more text data than numeric data, frankly speaking. All the emails that are going on between the employees, all the emails that are going on between the customers, okay, they are all data. Or like say voice data, every customer facing industry like a banking or life insurance, credit cards, they have a call center. So they have a customer facing call center where phone calls are made and a conversation is carried out. That conversation is recorded for, like you are told, quality and monitoring purposes, but there is more that can be done with that conversation. We can read the voice data. And of course, the image data, both the static image as well as the video image. Now, what we found is if we have the right kind of technology, the mathematical methodology which is required to generate insights out of this kind of information is hardly any different from what we were using already all along before that. Say monthly credit card spends or average credit limit utilization, all this kind of data. So the kind of techniques are the same. It's our ability now to apply that over greater type of data. That was a big revolutionary change. Okay, that simply meant we can do a lot more stuff which was unthinkable before this technology evolution happened. And that's what I meant, like in the last 10 years, gradually these two streams came to join hands. And now today for someone, it's very difficult to separate, in fact, the two streams, okay? And they are known by various terminology, like digital skills, machine learning, but what's in a name? This is the spirit of how this went about, okay? The second way where the data science community, the analytics people, we benefited by our coming closer together with the technology and the emergence of cloud technology especially is democratization. So deployment. So earlier, the solutions were simple. We had to work out the solutions. We, of course, were writing some codes, maybe in C, C++, SAS, whatever SQL, whatever the language of choice. And then finally, the implementation code was handed over to the technology team in the organization. And they used to hard code or they used to do something. And I never, frankly, in those days, bothered the steps through which my solution is getting integrated. I had to do some user acceptance testing for sure. Like if the credit card customer swipes his card, is it going through or not? That I had to do, of course, because I did the analysis recommending which transactions should be allowed and which should not. So I had to do an UAT. But beyond that, how it was done, it was not even our community was interested. Now in came with this deployment-friendly technology, we saw the emergence of APIs. APIs might have been earlier, but as an analytics person, I didn't care whether they existed or not, frankly. But now what happened is we could package our insights in micro modules called these APIs and hand over the APIs. Of course, they had a standard structure, which you guys would likely be familiar with. And they were like plug and play. The IT team could take it, and just like the olden time telephone operators, they used to change one plug from one. If you have seen the photo of, say, telephone centers, okay, in say 70 years ago, or none of us were there, but we have seen the photos. So they can use these APIs and they can plug and play, okay? That made the deployment very instantaneous. So we could quickly hypothesize on a business strategy, that this is going to work or this is not going to work. Most importantly, I mean, that was there before also, but we could test it instantaneously. And that was another sea change. So the technology part married with the quant part, it resulted in a revolution, okay? It's like the invention of electricity, or maybe the steam engine prior to that in the first industrial revolution, okay? There's a technology part. The second part is, of course, implicit in the first one, which is the kind of business questions we could now answer. Now we were no longer confined to answering. Of course, we were doing customer profiling. We have been doing, who is my customer? Who will be repeating a purchase with me? Who is likely not to stay with me at right? Who is getting angry with me? All those things, or what is the average spend, average product utilization? All these kind of questions are, of course, they're still there. It is not gone away, but we can do more. And what is that? I give a real life example. Supposing you are building a statistical model, who is going to stop using your credit card? Or who is going to foreclose your personal loan? Or who is not going to renew his life insurance? Okay, I can build statistical scorecards. But for some reason, that person may be very angry with me right now when his policy renewal is due, or even with credit cards, for example. Okay, that's because some agency made him 5 calls in span of 7 days. I'm calling from so-and-so company, will you like this product? Possible, right? And whatever reason, he is very irate. Or his payment did not go through, his transaction was not approved, he was in an embarrassing situation, or his policy renewal got delayed, something happened, he's irate. Now, a statistical solution is telling the general trend from a long-term basis, that based on his behavior or his profile or behavior in the last 6 months, here is how he is going to behave in the next 1 month or 2 months, okay? This kind of thing it is giving, okay? Anything, any regression, any such solution. But how can I marry such long-term stable insights with this kind of short-term disruptions, which may really affect his loyalty with my product or my services, okay? And here comes the role of my technology, and therefore I can do more business problems is, I grab the phone records. And there is a way I can analyze the conversation. There are routines in Python which you might be aware of already. Otherwise, you may just do a Google. And so someone has written something inside the Python. It applies a Fourier transformation or something. It splits the voice wavelength into constituent frequencies and spits out a vector, for example. Okay, I consume that vector, and that data I use as a causal parameter to correlate with similar experiences in the past and what happened subsequently. Did they renew the policy? Did they continue using the credit card? What was it? Now, this was not available earlier. I can respond much more real time. Now, please mark my words. This doesn't mean the earlier solution is now extinct. No, I'm just augmenting the effectiveness of the earlier solution. Commonly, people have a tendency to think, oh, that solution structure, that design is ancient. We don't need that. No, that's not the point I'm making. It's like the misconception people have with the word NoSQL. No SQL. No, that's not the truth. It's not only SQL. That doesn't mean SQL is going away. Okay? So this helps us to do this kind of analysis. Okay? Earlier it wasn't possible. Or for example, that customer has shot off some angry emails. Now, that data is nowhere in the traditional numeric data tables. But running text analysis, I can get some insights. I marry that with the insights of my more traditional stable solution, numeric solution. This amalgamation, overlaying, marriage, that is very important. You are not replacing one completely. So that helps me take on business challenges which are more dynamic, more varied type. It is not possible. And that is definitely a trend going on. Now, at this point of time, I want to make one comment here which participants will be likely benefited is, commonly our knowledge of corporate problems are like classification problems. So we talk of gradient boosting, we talk of support vector machine, we talk of clustering, random forest, okay, logistic regression, and maybe deep learning and all those things. But at the heart of it, these are all different type of classification problems. If you take your understanding one level of abstraction above, come out, okay? This entire stack that you can think is classification problem. Likewise, there is a different family of problems in the business world, forecasting problem. How can I forecast the monthly sales volume? So it's a time series kind of forecasting problem. Extremely difficult. I mean, I've been doing this job for my living for the last 21 years, and I'm still telling, not only I'm telling you, you can verify this with any seasoned statistician or data scientist, they'll say time series, because what happens in time going forward is extremely difficult to forecast, okay? And third category of problem is another one which commonly we do not take in the consideration landscape in our mental map is optimization. Any corporation has got finite resource, be it money, be it manpower, be it time to respond to a customer, be it market a new product. You always have a finite quantum of resources. How best you can allocate the finite quantum of resources to get the maximum output. So looking from this perspective, you can classify the entire possible stack of data science problems into one of classification, forecasting, and optimization. More correctly, you can say whether it's a decision problem or it's an optimization problem. I'm just keeping the forecasting problem aside. Is it a decision problem to decide to do or not to do, to be or not to be? That's a Shakespearean phrase, right? So that's a decision problem. The other one, spare a thought, is very equally important in a corporate setting. In a bank, you have finite amount of, a limited amount of, finite is and all of us are data scientists, so a little bit of mathematical words doesn't count. But limited amount of marketing budget, a maximum risk tolerance limit. You cannot spray credit cards to any Tom, Dick, and Harry who may be interested. You have to evaluate. If you approve their applications for loan or credit card, what is the credit loss that you are likely to suffer? Then there are elements like intangible. It's a customer fatigue. If you keep on marketing the same offer to the customer any number of times, you are not going to see them get enthusiastic and say, yes, please send me the product. Their response is going to come down. We track this. So on the x-axis, if you put number of times you contact the customer, on the y-axis, you put probability of his buying the product. Maybe from 1 to 2, it goes up, and after that, it will come down because he gets irate. Or if you market to him more frequently, he gets upset. So what do? You rest them. Okay, I called you in the month of May. I'm not going to call you with the same offer for the next 2 months or 3 months. You will not hear from my organization for the next 3 months. Okay, its analogy is like saying farming. If you plant your paddy too close to each other, you may think there is more output, but you're giving very little nutrients to each plant. Rather, if you pace out, it may appear that there is an opportunity loss. You're skipping some ground empty, but each plant is getting more nutrients, so they grow faster. Okay, the most scientific method. The same way it happens with human behavior. You give a pacing, and that can be one of the constraints. Now, using all these constraints, the business problem may be, how do I maximize my sales response? Or it can be, how do I maximize my revenue? Or it can be, how do I maximize my profit? If you can formulate this problem well, your CFO is going to love you. Okay? So you see, if you now go back and think between a decision problem, forecasting problem, and operating problem, between these three structures, you are actually covering, I won't say everything, that will be too hubristic, but I will say fairly more than the lion's share of problems you're ever going to encounter. Okay. Of course, I'm not undermining the good old MIS dashboard, because that's where it starts. That's where we start identifying if a problem exists. Okay. So these are the three things which I see from a one point of view. Now I come to the third aspect, the talent perspective. So earlier, like I said, the representation was very compartmentalized because the two streams are moving separately. Now, one, the two streams have joined hands, and B, because of the availability of better technology like cloud, better data storage, APIs, a wonderful programming language like Python, we can do more basically. Okay. And that is spurring the interest in more and more number of students. And students are joining up this community like never before. When I first started my career 21 years ago, and I had to make a few international trips that time. On a flight, a gentleman might casually ask me, it happened with me, oh, you're just passing out of the college and you are making so many foreign trips. You must be a software fellow. And I had to explain, no, I'm not a software fellow. I'm an analytics fellow. And that guy took a little bit time to digest what is that. Luckily today, the awareness and therefore your visibility, marketing yourself is not that much of a challenge. And this is going to gain momentum as you go forward. Okay. So that has attracted in its wake participation from diverse backgrounds. Okay. And what are they? So for a successful analytics model or adoption in an organization, you of course need the quant people. They will be working the problems. You need the people from technology background. Some of the products like a chatbot may be more of a technology rather than a quant. Maybe. Okay. But you definitely need the data engineering, the machine learning engineering. Without that, the science doesn't work. Unless I can deploy and generate it repeatedly and harness the benefits. Okay. So you need the engineering stream. The third stream is also very, very interesting. And these people do not come necessarily from a technical background. They have neither been software people, nor statisticians or physicists or mathematicians, or any such quant economists. How can I meet the economists? Because a lot of economics people are present in the analyst world. Okay. These are the people from the business background. These people are also playing a vital role as translators. So they understand just enough of technical solutions to translate it into a business lingo to the business users. And they can come from sales side, they can come from the service side. Normally in a BFSI, we partition into a sales side and a service side. Operations and claims and collections, these are all on the service side, and then there's the sales side. Okay. So we are seeing participation from the business community also, and they act as translators. Now the technical people can also get into the translator's role if they have a knack for understanding the business contours at a high level. They can get there. But that is one. And likewise, the business people who make a venture into the data science ecosystem, they come here. Okay. And finally, this is the next big thing which is happening in the industry in BFSI is formation of ecosystems. Until now, if you reflect all along, there are, I see questions popping up. I'm very much through, and then I will take all your questions. Okay. Sorry, I lost my train of thoughts. This is the next big thing. If you reflect all that thing I was narrating until now is like your data within the organization, and that's that much. Now what we are seeing is the next frontier is emergence of ecosystems. So like you already have in the manufacturing world, there's a supplier network, there's a distributor network, there is a manufacturing flow, right? It's an ecosystem. The same thing extends to analytics. So if you're a firm selling life insurance or home loans or personal loans or bank loans or maybe mutual funds, anything, I'm just restricting myself to the BFSI, that's my area, okay? You are teaming up. And why is that? Because you need more information, of course, with due respect for the information privacy. You need more information to feed just in time, basically, who needs what. Okay, and this is just not even the beginning. I'll give an example. For example, what a wonderful thing it would be if we get electronic health records. Say all the hospitals are digitally connected, like your credit bureau in financial records. Imagine we get a day when health records are all electronically stored at a central repository. When you are coming to apply for a life insurance or a health insurance, the underwriter has to look up into the right database, and of course the statisticians or data science, their models will be looking onto those databases and drawing in insights to make the prediction more accurate. But to do this, the insurance company and the healthcare delivery system has to be connected digitally, and they cannot be connected without getting a technology partner. So you see how the interconnectedness is appearing as going to generate value for the ecosystem. And when I say ecosystem, I mean the customers, I mean the shareholders of this company, I mean the regulators, everyone benefits, okay? I give an example in the finance world. In UK, if you Google, or you might be already aware, the regulators are pushing for open banking. I read it somewhere in the Google. In India also, I read the other day, it's not regulators, it's like major banks are coming together. It was a public news to do some data sharing. I mean, you can, nothing to quote me because it's in the public domain. You can just search in the Google if you're not aware. So this thinking already has set inside the corporates, okay? Number one, you need data. Number two, you have to invest in right talent. Number three, there is no knee-jerk reaction. It's not a sales incentive that you pay 10 more rupees to the salesperson and he will go and sell one more product. No, there's a gestation period in adding solutions. So this kind of mindset is changing already. Ecosystems are the next big things. Supposing that brings into question what will be the role of the big tech, say Microsoft or Amazon, Google. They form their own moats. You land up in this moat, okay? It's like MasterCard and Visa. We offer you the server, no matter which is the bank issuing the card, no matter which is the customer, where is the customer, we give you the common technology platform, your credit card is swiped, and the decision flows through. Likewise, just expand your thinking, okay? Try to imagine. You log into one particular, what I can say, aggregator. And that site is a marketplace offering you different type of services, from your healthcare, your finance, your travel, to your education needs, anything that you may look at this kind, to your social company, everything you need. Okay, not just the commodity that Amazon is giving as of now, for example. That's what. So that I say is a big one. And finally, the last part is regulation. Of course, regulators have to be vigilant, watchful, because and we as analytics community have to be ourselves be more ethical. And formally, anyone in finance, not only the analytics people, but anyone working in finance, we have to undertake anti-money laundering tests every stipulated frequency as mandated by the regulator. We have to take KYC tests, whether we know like all these basics. Likewise, we have to be also ourselves be ethical, not indulge in data leakage. But having said that, you know that in a vast ocean, there will be some dishonest people. So there is the dark web already flourishing. Okay, regulators will also be taking note of it, and accordingly, from time to time, regulatory restrictions will be coming. I hate to call them restrictions because I may be a data scientist, but even my data is there in the database, just to be protected. So these are the 4 things on which I see the action happening around, and that's what we have seen, how we arrived where we are, and what's the road forward. So that was my bit of sharing. Okay, and it's a continuous journey. I've spent time extensively in the lending, banking, and insurance. So in the BFSI, I can take on questions fairly, being an industry insider all around. So time for question answer.
So Sayan, this was very, very interesting. And one thing that stuck with me was about when you said about the healthcare and insurance sector to be merged and have that health records digitalized and to be used when it is being used for the insurance and other purpose. So I do remember an incident when I met a person. He was from Switzerland, and he was an Indian working in Switzerland, and he was saying that he wants to do that because everywhere he sees there are different hospitals taking in all the information, but not there is no central repository for the same where anyone's health
Correct.
records can be managed.
Correct.
So yeah, something like that that can actually help everyone.
Yeah.
But that never came to fruition. He wanted to do that, but anyway. So yeah, we have few questions here. So have you received anything on personal, or shall I take it from here now?
You can take it from there. If you read it out, then read out the name of the person who is asking the question and the question, so everyone can listen to it.
So Ranjan just asked what you look for in a candidate when you hire for your own team.
Okay, like I said that there are different type of profile who are required. I think there should not be any ambiguity in that part. The question therefore is, in what ratio do I hire? Okay. Now it depends the objective of the organization you're in. Analytics is an expensive affair. It is not just setting up 5 MIS analysts and you churn numbers for me and then I will make sense out of it. So it's not for nothing that Google and Amazon's expenses, whether it be the salary bills, whether it be the other infrastructure, they run into millions. Okay. So as an organization, we have to fix whichever organization we are part of. Do we want to build in-house more of it, or do we want to outsource? If you want to outsource more of it, you will be running a lot of costs in the later years, but initially it will be very fast time to market because you'll be getting ready solutions from the specialized vendors. Okay. But they will be having a profit loading in their solutions, and that will escalate as you go by. Further, you are constantly at the mercy of some third party. You don't have anything, your IP. So if you develop something, others can potentially get to know it. Okay. and it is very much legally possible. The vendor just doesn't name the company for whom they have worked. They just say, we have seen this kind of parameters come significant. Now, technically, there is no name divulged, but you have lost your competitive uniqueness in the market because someone else is going to replicate your data insights. That person may not have so much data to derive at that on your own. So that's a risk you have. But nevertheless, if the organization thinks this is the way to go, okay, then you will be hiring more of the translator's profile and the technology profile, which can take ready-made solutions as API and fit into the system. You'll be hiring very few quant people. On the other hand, if you want to build as much as possible in-house, which every large organization, if you can give me an example in the BFSI world, whether banking or insurance has got in-house, because it protects our intellectual property. So in that case, of course, the quant will be the overwhelming large majority, very closely followed by the technology part. And again, I'm talking of the ratios, okay? There is no count here. And I will take very little of the translators. It doesn't mean 5 translators or 50. I'm saying in ratio, that's all I can say as much. It depends on the company to company. But it is very much in line with what your organization's priority is. What are the risks of developing in-house? Now, the other side, just as I told, if you have everything outsourced, there's a risk of having everything insourced. One is if your employees attrite, you are at a risk. You have to do everything. But these specialized companies, they know that there will be attrition and all those things. So they will take all this headache. I mean, the technology world, which bank has their own technology? Everything is run by either TCS or Infosys. I mean, and this is world over. I mean, you take the big US banks, big European banks, they're all outsourced to these companies. Either you have a TCS or an Infosys or a Cognizant, HCL Tech, Wipro, they are running these things, right? So that boils down to who you are selecting. Oftentimes there's a temptation, I will go for a cheaper product, but quality vendors will charge a price. They will not give you for cheap because after all, I mean, they are also having to hire from the market. They have to build the product, try to understand. One classic case I heard, this Nirav Modi saga, apparently the bank he defrauded, and this is the news I read, I may be wrong, but I know that this is the news published. They refused to buy certain modules of fraud detection. That would have cost maybe 2-3 crores, 5 crores, 10 crores. But imagine without that expenditure investment, how many hundreds and thousands of crores are lost. So sometimes these expenditures have to be convinced to the management that this is an investment, not expenditure. Bear that in mind. And that has to go in tandem with the size of your organization and how much appetite it can take. Okay? So that would be my answer.
So next question is from Harshit Ved. He wants to know, in today's world and thanks to emerging technologies, there are a lot of incoming data signals. In general, to forward the large target, few of the signals are dropped, but due to the same semantics for an individual also get disturbed. How do you see this problem of semantics and contextual analytics versus larger coverage?
No, I'm not following this question, sorry. Can you read out once again?
Yeah, sure. He's saying that in today's world, and thanks to emerging technologies, there are a lot of incoming data signals in general to cover the large target. Few of the signals are dropped, but due to the same semantics for an individual also gets disturbed. How do you see this problem of semantics and contextual analytics versus larger coverage?
If I may understand, and you may speak up, Himanshu, right? Harshit, you may speak up if you want, but correct me if my understanding is right. What I interpret is like, how do I ensure the uniqueness of the micro pockets while drawing insights on the law of averages, something like that? Is that the right way I can interpret the question?
I'll just check if he is there. Harshit is here.
Okay, Harshit says that's correct. Fantastic. Now, the example I gave with a statistical scorecard versus the voice call in the course of my talk is fitting inside this context. On an average, I have seen these are the kind of people who will buy another product from me, or he will continue to use my product. Okay. But there is one individual who does not, who satisfies all the other causal factors, the triggers, okay, to qualify as a repeat user of his credit card or a renewal of his insurance this way. But because of his experience in the last 1 or 2 months, okay, maybe he got horrible experience in his health insurance claims payout and he doesn't want to renew his health insurance. Okay. Otherwise, he satisfies all the other parameters that place him more likely with a happy customer, likely to renew his policy. But this experience is not applicable to everyone for various reasons. It can be that his hospital bill was inflated by the hospital, or whatever be, and the insurer did not settle it. Or maybe insurer had a very conservative policy when it should have paid out more of the claim, it did not. Net, this particular individual is unhappy. So how do I accommodate that signal, which may appear actually not as a pattern, but as a noise in the bigger context? That's basically the problem. Here, our approach is to use an ensemble of models. So if I have a solution which tells me the long-term stable trend, and I overlay with the short-term predictions, somehow I mix them. I may do a cross tab, I may fit them in the same model and make one more model. It doesn't matter how I mix them, but I'm making an ensemble of the model. Okay. Then in the resultant grade or insights, I'm able to largely capture the simultaneous blending of the long-term and average level insights with those micro trends. That is one of the ways I tackle with these problems. The more difficult thing is, remember I told there are 3 types of problems: decision, forecasting, optimization. In forecasting, this is a challenge. So today in July 2021, if I look at the past 12 months of data, how can I place my trust on the data that is known to be an aberration because of lockdown, pandemic, everything? And there I don't have an easy answer, frankly. I can't say that one. But in the other case, I will have 2 solutions or 3 solutions, ensemble of solutions. And that's if you see solutions like generative adversarial networks, solutions like gradient boosting. That's precisely what they're doing. Okay. It can be overcoming the sample bias through cross-validation, or it can be the long-term versus short-term trade-off. Statistically, there is another related thing to this one is the bias variance trade-off. Again, ensemble, and that's what you have to do to give due importance to uniqueness of a customer and without calling it a noise in the overall scheme of things. Let's disregard, because every customer is valuable. Okay. Sometimes what we do, we put wrappers around our model. Wrappers. That is, no matter whether my model is telling it's a risky customer or less risk customer, it's a high spender or low spender. If that condition is, and that I draw from the business. So as I build a solution, I'm constantly in touch with my business colleagues, because my analytics cannot be ivory tower aloof from business experience. And their experience may not be reflecting in my solution, because that's just 1 or 2 or 5 instances out of 1,000, but I put them as wrappers. So my solution equilibrium is not disturbed. At the same time, I'm doing justice to that uniqueness. Okay, so that's my way of answering.
Mr. Sen, so we have a couple of more questions. Let's start with Reggie. Reggie is asking, how will the data privacy policy or law impact the use of data in business models? Do you foresee any upcoming challenges?
Yes, it will change. And this is, you're asking a futuristic question, so I have to be excused for giving futuristic answer. The other answers I gave you based on my actual experiences. Now here there is, I see one which will be constraining on our data scientists' ability to create solution. The other which will be helping us, which will be expanding. The first one is, for example, the amount of data I can, or the type of data I can use to build my models. So as I speak, already for many years, 10 years, 15 years in the United States, they have restrictions on using certain type of variables to bring solutions to approve or deny a loan request. You cannot have variables talking about an individual's gender, race, even age. It has to be based only on the credit repayment capacity of the borrower. And to the extent, I have had experience sitting with the law firms in New York, where they used to audit the models after it has been done, that you are not biasing against Hispanics or against the Black population. And frankly, it is a very irritating job for a statistician, because if the data has to show there is a problem or there is a trend, it will show. Mathematics doesn't fear law. Okay, just as law also did not fear mathematics, but maths also doesn't fear law. But we were caught at the crossroads, so we had to find out other variables which are credit performance related, which can mask directly referring to variables like racial grouping, age, religion. Okay, you can't do these things. Basically, you can't even ask the questions on, are you a Methodist or are you so and so? I mean, which church you go to, you can't ask this kind of questions. Okay, so you can't use any age bias, any race bias. You cannot use anything apart from your credit repayment capacity. The other part is the kind of data storage. So there is a lot of discussions in India about the Aadhaar database, the biometric database, okay? And part of it, this fears is justified, I believe, even as a data scientist, although it may help me build models, but those fears are not unfounded. So there is a discovery process. There's a negative, there's a constraining one. The positive ones is, take it differently. What if this accelerates or this actually ushers in a faster and wider adoption of something called blockchain? Because in blockchain, you cannot tamper the data the way you want. You can overwrite. Any Tom, Dick, Harry cannot access. They will be always tracked. I mean, I don't know how to do it. Other people are doing these things. But I can only think that with the regulatory restrictions coming, maybe blockchain technology is one way to safeguard who is using the data and what type of use they are making, attempting to steal the data or tamper the data, all these things may be detected. So we have to see how it evolves over time.
Next question is from Anurag. He's asking what algorithms or methods can be used to forecast NPS returns more accurately?
Now, NPS returns, okay, good question. I'll just take a step back. When I was telling you about the decision problem, forecasting problem, and the optimization problem, there are two categories, the decision problem and the forecasting problem. They are not deterministic. They have certain degree of stochastic component. Stochastic means which is not deterministic, like say V equals to U plus AT, for example, or F equals to MA, the physics, those equations. They're deterministic. We know that if this is the input, this is the output. E equals to MC square. If you believe in this, we know if this is the input, this is the output. In stochastic component, a little bit of deviation is inevitable. Okay, inevitable. So our attempt as probability theorists or probability theory users more correctly is to minimize this probability of deviation, basically. That's what we call when we say the p-value of the regression coefficients, for example. Okay. On the other hand, optimization problem in the context that I am referring to in the common parlance is a deterministic problem. Okay, if this happens, then that should happen. It's a complex algorithm, no doubt. Okay, in NPS return calculation, you have to take it in two ways. One is isolate with respect to what you are trying to analyze. I've not done this problem myself, so I don't have the exact answer, but this is how I will approach it. What are the different inputs that goes into the NPS calculations? What is the nature of those inputs? Stochastic or deterministic? Once I get the inputs, second step is the computation step. Now this is undoubtedly deterministic. In no machine learning, your computation step can be stochastic. In a linear regression, it will do an OLS optimization. In deep learning, it will do a gradient boosting, stochastic gradient boosting or mini batch, whatever you specify. It cannot deviate from mini batch to batch gradient boosting. So the extent of deterministic thing is solely defining the way you compute. It is only at the inputs that you're using for getting the output. If your inputs are deterministic, it's a calculator. And if your inputs can be varying, one of the ways to do is Monte Carlo simulation. Without going to the details, what Monte Carlo simulation is a very vast topic. What it does is it tries to create different scenarios of input parameters. For each input parameter generated, it computes using the deterministic computation logic what is the end result. Now, input parameters will be generated following a certain probability distribution. Therefore, your end output will also be mimicking that probability distribution. That's what happens in your options pricing, Black-Scholes, and this kind of models where you do the options pricing. So that is the way I will, and this is a very safe way to answer any complex thing you throw at me, right from if I shoot a rocket from Earth to Moon, where will it land on the Moon? Even that you can do with this kind of approach. All you have to do is you have to isolate inputs, stochastic, deterministic, computation, always deterministic, and then you have the answer. The origin of this technique is what I read is during Second World War, when Project Manhattan was trying to test the impact of the atom bomb in the Los Alamos laboratory. They were not able to get a closed form analytical solution to see the impact of the radiation. Okay, so in absence of an analytics solution, they resorted to numerical solution, and that's how this Monte Carlo that's what I know. I mean, someone might have tried it very successfully earlier also, but this is one example I know where Monte Carlo technique was very successfully used. Sorry, it's not a very useful purpose, but that's the example. Yeah, where it is.
Mr. Sayan. So there were some more questions on what are the qualifications to be data scientist and checklist for mid-career transitions. But I guess you answered that one when
yes.
Yeah, when you were talking about what will you look for when you are hiring for your own team.
Yes.
So I'll take a couple of more questions. We are close to 7:30 now, so I'll take just two more questions. Are there? So Amrita Schiller is asking: are there challenges for central repository creation, especially with banking systems where data security is paramount?
See, banking system, the biggest challenge is not data security being paramount. The biggest challenge is, if you see the city of, say, what can I say, Paris versus city of Taipei or Seoul, for example. Okay, Taipei or Seoul looks lot more futuristic, like everything glass and high and all these things. Paris or this cities look more medieval from outside at least, right? That may be by design, but that is the factor of the function of the legacy. In banking world, the journey to analytics started earlier than most industries at such a scale. I mean, you didn't even have the word e-commerce around when I started working in banking analytics, and it started before me. I did not start it. It was there for easily 10 years before I started, or maybe 8-9 years easily before I started. Okay, so the legacy factor weighs in. it's not easy to do the transformation with a legacy framework. And that's why a common joke goes around is far more data house creation projects have been initiated in the world than actual complete data warehouses have been built. Okay, so every organization and every CEO likes to invest there. There's merit in investing, but the cost of shifting over requires extreme courage, confidence, and a lot of other things. Okay, so to answer your question, having centralized control will actually help security part. Okay, you can have well-guarded access and all such stuff, but if you don't have it, try to bring it. Forget about so high level things. Just a simple thing like when you migrate from one legacy system to another, same data is captured in two different sounding data fields. And if you're a modeler, you would have experienced, or if you're an analyst doing MIS, you would have experienced what hell of a problem that is. Now, those are the dirty data work, which we the insiders know. They don't make headlines in any seminar, conference, nowhere, okay, or any blog post. But we know that as we talk about digitizing and automating, these are also needs to be addressed. So legacy, if we can overcome the legacy, it can be done. And security, I think, will be benefited of it if you go through the simple system. Go ahead, please.
So the last question of the day, Kamakshi is asking, how have the text and voice data analytics methods benefited the banking industry?
Well, ever since text and voice, and for the matter, image data also came to be used, I have been in the life insurance around that time. Okay, so banking, what I hear from my colleagues in the banking system is text data can be used in the same way as we use in the life insurance industry. Customers are writing emails to you. You can read those emails. You can identify the keywords of frustration, anger, irritation. You can do topic modeling. So today, and this is very unique, it's not only bank or insurance, it can apply to any B2C industry. When an email is coming, typically there is a huge manpower in the operations desk. They read those emails and they classify whether it's a query kind of question, it's a complaint kind of question. What is the broad purpose? For that, they have to read the question and they have to comprehend. This takes time in the human brain. Even if you allow very little time, the number of mails that a bank gets is humongous, okay? Or the number of calls a call center gets. If you can develop an algorithm and implement it, this sorting, at least at a minimum, will become very easy. Second, if the question is a query, when is my next renewal date? So flat questions. You can develop automated messages to that. Okay. Third, the voice can be used as a password. So everyone's fingerprint we know is unique. Likewise, our voice print is unique. And if you split our voice in sound waves made of constituent frequencies, right? Amplitude frequencies. If you can split them, you will see that there is a unique voice print for an individual. And so it can do an excellent job, just as using image recognition, your IDs can be used as a password. I saw this in Dubai airport. When you clear the customs, they look in the eye, and that is my, provided you have been there earlier, and that just says that this password and this passport number and this individual. So these are actually in practice. So you can do the same thing in your branches when customers come, or when they call you. As soon as they call, within a few words, you can just quickly connect. And this is very possible. It's doable. It's not exotic anymore. You can find the Python course in the GitHub also. You can just get that and you can map so and so as call. And simultaneously in the call center person's screen, you flash out, he's the person, this is the next likely product he can buy, pitching this one. So all these things happen so fast. So that will be my answer.
We have one more question. We can take this. Okay. So Aditya Ahluwalia, he has a two-part question. One, he's asking, while tech-driving data analytics capabilities are advancing significantly in the financial services industry, there has been a raging debate of late about data quality. Often generic data sets are used for different purposes, which leads to biased or inaccurate outcomes. What can companies do or are already doing to overcome this problem? That's the first part. The second is several elements in regulations like GDPR and PSD2 PSD2 aim at returning ownership if data back to customers and restrict companies using data without explicit customer authorization. There is
Sorry, I'll just interrupt you, Shivam. The second question, I lost track. A long question. Can you just start reading once again? Extremely sorry.
So second part says that several elements in regulations like GDPR and PSD2 aim at returning ownership if data back to customers and restrict companies using data without explicit customer authorization. There is some debate in Europe and the US that this could curtail the prospects of fintechs, such as in areas like open banking. Can you please comment on this with special reference to India?
Okay, both are good questions. The first one especially is a very grounded question. It's very dear to me. Data quality. People say big data. I like to say clean data. We need clean data. Nice data with metadata and labels and everything. Okay, no ambiguity, nothing, no formatting issue, nothing. So it's a discipline issue, frankly speaking. We have to inculcate a sense of archiving and storing a data and recall it only for the purpose that it has been used for. While occasionally we may refer to that data to test hypotheses in unrelated areas, but expecting that you can force fit that data to definitely answer some unrelated hypothesis is outright not the right way to look at the whole thing. That's the way I look at it. Okay, for example, we know that the credit bureau has done a fantastic job in terms of predicting customers' propensity to default. Okay, can I use this data to predict customers' propensity to renew life insurance or health insurance? It may show a good fit, right? Or it may not, because that is not built for that purpose. And same holds with a solution. Oftentimes, third parties will come and try to force fit, and I've seen too many of these presentations, without understanding the unique problems of that particular industry. They try to kind of dress up a solution which has been applied elsewhere successfully, that it can work here. Okay, and that is again not the right frame of mind. You can always consider that with an exploratory mindset. Let me see if there is a connection, and that's the science part of it. But the expectation building before you have found the science, I think that is not the right part. And businesses which insist on such practices, they will soon get frustrated with the wonderful potentials of analytics, and they will lose interest in growing that practice more and more and fall behind. The second question is, see, this will of course affect the fintech, but at the outset you have to remember that what are we doing in the name of fintech, frankly speaking, today? I mean, is it a convenience issue we are solving for, or is it a distribution issue that we are solving for? Why is the fintech so popular today? Okay, now they, as standalone entities, they will stand to lose. Many different line of business have already completely lost out because of regulatory change. I'll give you digital wallet, for example. Ever since UPI has been launched, I don't know what's the need of digital wallet. Okay, but they were a great proposition when they were first launched. Okay, then you first made the portability open, that each wallet can connect with any merchant and regardless of where it is being paid. Okay. And now eventually you are making one step further, UPI. So yes, fintechs, their operating model will be affected. There's no doubt. But what I have seen, these fintechs are usually the people at the top. They're extremely intelligent people. They will find a way how to fit in value creation in the change paradigm of things. I mean, there's a human ingenuity part. They will not be stuck at, oh, my product was defined on these lines and I had these and these assumptions to run my business. Now regulator has punctured every potential. Don't worry. Almost every good fintech player, the founders, the key managers, they're some of the smartest in the industry. Okay, any major brand you say, they will find a way how to change their value prop and fit into the new scheme of things. Having said this, fintechs will have a hard time if the big tech comes into finance, which is what is called techfin. If tomorrow Microsoft or Google or Amazon or anyone else comes and says, I will give you a platform, no matter which bank you hold the account, I have modules of services to do your authentication, to do your payment processing. You would be knowing, like when you ride the Uber app uses so many different services of tracking the location, processing the payment. It's not one app. There are applets or microservices fitting inside that Uber or Ola app. Okay, so in this system, fintechs have to find their footing somewhere. They cannot control the system as a separate entity. Okay, and the second part is vis-a-vis the large banks. See, everything fintech is doing, nothing is non-replicable by the large banks. If you look at it, I mean, they can give you the digital payment interface. They can do a lot more than the fintechs can do. So fintechs, they came on the proposition of convenience. Okay, some part of it was true, some part of it I never believed. I don't believe, like this ability to predict using surrogate data like social media data. No, you cannot get data so easily from Facebook. You cannot get data from so many social media platforms. So those are good for the PowerPoint to impress the management, who themselves may not be aware, but that's not the reality. So those things are the moonshine part of fintech story. The convenience part, the technology, is after all, a bank can employ a TCS or an Infosys or a Wipro or a Cognizant or a HCL or one of these firms, Accenture, IBM, and they can get the same thing done. Because they have the legacy system, they may not be so agile, but if there is majority of customers are liking that medium, that way, they will smell money there, and they will also, the bankers also very intelligent people, right? So fintechs have to evolve, and they are guided by very smart people. I mean, if you look at the profile of all the founders, they are extra smart, I mean, intelligent. Elon Musk started PayPal, so that gives you like the whole thing, it's smaller anyway.
Thank you so much, Mr. Sayan. That was a very, very extensive knowledge that you have imparted to us in a very, very short time. And I hope our attendees, they were benefited from that. I thank all the attendees to impart their time for this session. I thank Mr. Sayan for taking out time to address our learners, our alumni, and us, and taking out time for this session. Thank you so much, sir. It was an interesting session, and we are lucky to have you today.
Thank you. It was my privilege and my pleasure joining all of you. And if what I shared has been of interest to you and helped you, it's a bonus privilege and pleasure for me. Thank you.
Thank you, sir.
Take care.
Thank you, everyone.
Yes. Have a nice weekend, all of you.